Yeah, thank you for that introduction. Really happy to be here. I was here probably a couple years ago, and then 3 years ago, and then a time before that, where I actually gave what might be considered an earlier version of this presentation. You could get to it from my blog, which we'll talk about later. And really happy to give like the 2020 version of this talk. So as mentioned, my name is Jeff. I'm on the web developer relations team at Google, based here in New York. Do a lot of stuff with progressive web apps, with service workers, and yeah, I've been obviously thinking about this space for a while. So, you know, calling this progressive web apps with Eleventy, do not need to build an app, but we'll get to that later. I guess another version of this talk is, you know, what if you did all the Eleventy stuff, but you move that inside a service worker? What would that look like? What are the benefits? What are the drawbacks? You know, that's kind of what's going to motivate what we're talking about. All right, before I get started in what I'm actually going to talk about building, I'd like to just get a bunch of terminology, kind of a link dump or slide dump of some things out of the way. I know that everybody here probably has a slightly different background. Not everybody has been spending, you know, all their time diving into either Jamstack terminology or progressive web app stuff, things like that. So let me just lay out some of the things I'm going to be talking about, and bear with me. I guess people could ask questions in the middle if I do not explain things thoroughly enough. Totally cool with that, or you ask questions at the end, whatever works. And I will have a bunch of links up there to Google's web.dev site, which some folks on my team have been maintaining and writing some new content for. There's lots of other information available, but I feel like I have to promote the web.dev links. So first of all, progressive web apps in general, learn more web.dev installable. And it's a really kind of a wishy-washy term in some cases. Nobody knows exactly what it is, and there has been kind of efforts in place by different browser vendors sometimes to kind of define a baseline for what would make a progressive web app, and it's usually defined in that way to then lead to another thing related to installability. So it's kind of the basic idea. It is a web app or a website, as we'll talk about soon, that you've added some additional technology to that you probably wouldn't have used otherwise, that raise the bar to the point where a user should feel comfortable installing that web app on, let's say, their phone, although desktop PWAs is a thing now, and you know, get the PWA icon in the Mac dock or the Windows Start menu and things like that. So the two specific requirements that people talk about the most, one is a web app manifest, the other is a service worker. So those are some extra things that you need to add on to any existing web app or website, and technically that's all you really need to do to build a progressive web app. What's a web app manifest? Learn more, web.dev/add manifest. It's metadata. It's basically you as a developer saying, hey, here's some information that usually the operating system would find useful if you're going to be installing my web app. So things like the title of your web app, kind of a short name, a long name, the name that would appear within the launcher, icons, if you want custom icons at different resolutions, you can provide links to that within a web app manifest. There's some additional customization that some of this is specific to Android, some works on some desktop platforms as well, but things like the splash screen colors, you know, most folks are used to loading a native application, probably see some sort of loading splash screen when that happens. You know, on the web, you're probably used to seeing just a blank page with like a loading message down at the bottom. So we have ability to say, hey, this is my background color, this is the icon to show when loading. And there's some other metadata that you could put into the web app manifest as well, especially as people develop kind of enhanced capabilities for progressive web apps. It's just a convenient place to put metadata, basically. But for the purpose of this talk, that's what a web app manifest is. Service workers. This is what I spend most of my time working on and just talking about and thinking about. So I have probably a very distorted view in my head of how much people know about service workers. So again, this is probably an area where, if anything, I might end up going too fast and not explaining things very concretely, so please stop me if that happens and folks have questions. But without giving like the full 30-minute overview of what service workers are and what they could do, think of them as some JavaScript that you write. You have control over it as a developer. It's event-driven, so it's not running all the time. It's something that the browser will start up and fire your event listeners on in response to the user doing certain things. And you deploy it alongside your website, and within your website, you kind of register it. So you're basically saying, here's my website. I'm going to use this service worker at this particular URL. And then the browser has a whole process in place for actually downloading, executing the service worker, evaluating it. There's an upgrade process, which we're not going to really get into, but that's kind of how you version things and allow your service worker to move from one version to another. And the real magical part about service workers, the reason people care about them, actually kind of the way that they're different from other workers like web workers that you might have heard about, is that they have the ability to intercept network events. So there's a fetch event that gets fired whenever your web app makes a request to any network resource. And that gives you the ability to, within your service worker, within JavaScript that you control, respond to it however you want. And that sounds a little scary. It is a little scary. There are lots of examples people can point to of things going wrong when deploying service workers. There are lots of things that people can point to of things going wrong when you're deploying updates to your backend web server as well. Think of it like that. Usually your service worker does similar things like that. And in particular, we're going to talk about generating HTML, stuff that folks are kind of familiar with either via static site generating or via using some sort of CMS-based system and a server-side system. The important thing is you could do that in a service worker. The other important thing about service workers is that they have access to this thing called the cache storage API, which kind of opens up the door for a bunch of additional smart caching beyond what you could get with the HTTP cache. So folks are familiar with like cache control headers and the ability to say, don't cache these particular URLs, or, cache this particular URL that I know is never going to change for a year. That's all stuff that you can do with traditional HTTP caching. Service workers have access to something in addition to that. And actually, web apps themselves have access to the cache storage API as well. So although we're going to be talking a lot about using the cache storage API from within a service worker, you could actually query and add things to the API and update stuff from within your web app too, which, just an aside, it's kind of cool. Most people don't seem to know that you can do that, but it does open the door for some cool integrations if you start using the cache storage API within your page. So anyway, the important thing to know about cache storage API is that there are two really important primitives. One is the request, one is the response. If you've ever used the fetch API and played around with that in modern browsers, you probably have seen request and response objects, whether you knew it or not. Exact same request and response objects are what end up being the keys and the values in this cache. And that's pretty cool. It's nice that it's the same type of object, because it means that when you're making network requests with fetch, you could then take the response, stick it in the cache. You could respond to fetches via those cache responses. Things work nicely, hopefully. Next thing I want to talk about is something called Workbox. Workbox is I have a sticker on my laptop, which now I feel guilty because I didn't bring stickers. Sorry. It is a set of libraries that I work on as kind of my main job, and you could think of them as kind of two different types of libraries. One of them is a bunch of build tools that integrate into your build process, and it can generate a service worker for you based on a declarative configuration. If you integrate into your build process, you could also just say, don't necessarily generate a service worker for me, but take a look at all the artifacts in my build. You can pass in a bunch of glob patterns. You can use the Webpack plugin to grab a bunch of assets and say, all the things that match these criteria, those are the things I want to be cached by my service worker. And moreover, Workbox will take care of generating hashes of all those files and making sure that it only downloads things that have actually changed and stuff like that. Sorry, did you have a question? Or no? Okay. Yeah. Again, feel free if there are questions. So Workbox has some of those tools. As part of the demo I'm going to be showing, we're going to be using some of the build tools for getting a list of assets that are generated as part of an Eleventy build. And we'll talk about how we're going to use those. And kind of the other set of tools or set of libraries that ship as part of Workbox is the libraries that run within the service worker itself and handle things like routing, things like caching policies and expiration. We have some plugins for like making Google Analytics work when you're offline. We have some plugins for like retrying requests that fail because you happen to be offline using background sync API. A few other things along those lines. You can learn more at web.dev/workbox. And yeah, the main thing, the code that I end up showing a little bit later on is not going to look really like plain service worker code. It's going to look like a bunch of Workbox function calls and things like that. So it'll make a little bit more sense if you familiarize yourself with Workbox. And you know, I'm obviously biased, but I think Workbox tends to help in a lot of these scenarios where you're building any type of progressive web app. So check it out if you're interested. All right, this is probably a little bit better known within this audience. It's Eleventy. A lot of folks have been talking about Eleventy recently, past couple of years, I think. I don't really know the exact origins. I know that it was started by Zach Leatherman. I think Zach's brother is here somewhere. Maybe. Hi, Zach's brother. Good to meet you. I was told you would be here. You could tell Zach that Eleventy is awesome. So. And yeah, it is, as per the website, Eleventy is a simpler static site generator. So I was really excited to see Eleventy when it came out. I kind of view it as a JavaScript-based alternative to Jekyll. So actually, the last time I spoke to this group, I guess back when it was maybe called the New Dynamics still, before JAMstack.NYC, I gave a talk that somewhat similar to this, but everything was based on Jekyll. I had used Jekyll for a few years. For those who are not familiar with Jekyll, it's all Ruby-based. I'm not really a Ruby programmer. I think most folks who are working on web stuff would probably prefer if their build tools were also in JavaScript or something closer to what we use on a day-to-day basis. So that was the kind of the selling point for me. It was like it offered a very similar experience, but everything was JavaScript. I could kind of dig into how the code worked a little bit better. It was a little bit easier for me to configure. And it's been really great seeing it grow over the past several years. So it's used by a bunch of folks now. Actually, all the web.dev links that I shared are powered by Eleventy behind the hood. So Google's been using it for a bunch of things as well. So, and the other kind of relevant thing about Eleventy, so it's like, it's a framework that will run a build process for you and has information about your content and knows how to run Markdown and stuff like that. But one of the things I thought was really interesting is that it's kind of pluggable in terms of which templates you want to use. So I was coming from Jekyll, as mentioned, and Jekyll uses liquid templates. I didn't really want to continue using liquid templates, so I ended up switching to Nunjucks within Eleventy. Nunjucks, I found, had a similar enough syntax to what Liquid supported. So migrating things over was not that much of a big deal, and it felt like a pretty, what you would expect from a templating language, I would say. Not necessarily good or bad. It's great. It's good. It's fun. The really important thing for the purpose of my talk, though, is that Nunjucks has runtimes both in the browser, and it also has Node.js libraries for doing it. So, Eleventy will run the Node.js bindings when it generates a site for you. I'm going to be using the browser runtime inside the service worker, so that's cool. I was glad I was able to do that. Kind of do that using Liquid and a weird auto-generated like Ruby to CoffeeScript to JavaScript port of the Liquid templating language. I would rather not do that. So I was happy to be able to use Nunjucks. Okay, that's a list of things I wanted to talk about right off the bat, and wanted to dig a little bit more into, why should you care about progressive web apps? So we talked about it's something that you kind of have this install type experience if you want to. Like not everybody has to actually install your progressive web app and add it to the home screen. But kind of the superpower of progressive web apps, the thing that you could do, and this really has to do with service workers more than anything. So the thing you could do with a service worker that was pretty hard to do with other traditional loading techniques is to have loading that's reliable and fast and also reliably fast. So what do I mean by that? The reliable part refers to the fact that you can, if you have a properly configured service worker, write a web app that will work independent of your network completely. So if you have, I always, use this, probably this dates me in a little bit. I used to talk about going on the subway and you're on the subway platform, you don't have cell phone service and you can't load anything. Obviously we have pretty good cell phone coverage in the subways nowadays. So forget about that. Let's say you're someplace where there's no cell phone coverage. You want to load a web app. Most people traditionally would not even think to go to Chrome. They think, or Firefox or Safari. They would be like, yeah, I'm offline. I'm not going to be able to load anything. But with a service worker, you have that reliable loading. You will be able to load whatever your service worker wants to load, and you're in control of that. So it's obviously very tricky make sure that you're loading the right thing. You're not always able to load something that's useful, because if you do have dependencies on the network to pull in the latest whatever, that part's still not going to work. But if you're careful about how you plan things out, using a service worker, building a progressive web app, you can reliably load something useful to all your users. So that's step one. The other thing related, sorry. If they previously gone to your site and registered a service worker. So your service worker could cache things in advance. Mm-hmm. Yeah. If they've never gone to your site before, then no. Yeah, but if they've gone to your site before, you have control over how much you're going to cache. I'm going to talk about that a little bit later. You want to be respectful of dumping 50 megs into the user's cache when they browse your site for 5 seconds or something like that. So that's definitely a consideration. Yeah, the other thing, PWA superpower, service worker superpower, it's just performance. If folks have done anything with traditional HTTP caching before, you tend to almost always serve your HTML with caching disabled. You pretty much always want to pull down fresh HTML from the network, and then like most of your sub-resource requests are going to have hashes in their URLs and be served with long-lived HTTP cache and stuff like that. But that first initial navigation, so navigation request is the request for the HTML, the thing where the browser, you're starting from scratch, you're not seeing anything at all on the page, you're just seeing that loading message at the bottom. Without caching, that's probably not going to be as fast as it could be. With caching, if you're able to skip the network entirely, you're going to see performance benefits. So that's another thing that service workers give you. And finally, reliably fast, kind of just smushing those together a little bit, but there's a little bit of nuance here. I just want to make the point that if you are building something that's fast on 4G, I guess people have 5G now, fast on 5G. If you're fast on your corporate network, that's great, but it doesn't mean it's going to be fast for everybody. I don't want to say that service workers always have absolutely consistent performance characteristics. There are lower end devices. It does involve spinning up a new thread for the service worker to handle navigation. So there is a little bit of startup cost that could be variable, but it's nothing like the variability that you might get from being on a flaky mobile network connection and waiting for that HTML to start streaming down. So you take that level of variability out of the picture, and you kind of have like an upper bound on how bad the worst case scenario for what your loading speed is going to be, and it's going to be pretty good. So that's what we mean by reliably fast. So hopefully that's motivated you to cache first HTML. That's what I was talking about throughout all that. Hopefully that's motivated you as to why you should care about deploying a service worker. The goal is to get to cache first HTML. This is the hardest thing about deploying a service worker, figuring out whether this is even possible. And I'll be honest with you, it's not always possible for all existing architectures. If you happen to have a legacy web app, and it's all based on JSP pages that are doing database queries in real time and spitting out some HTML after it does a bunch of backend processing, chances are you're not going to be able to move all that logic into a service worker. And what I tell a lot of people is, think about opportunities where you know that you're going to be working on a site re-architecture anyway. And that's the time to start thinking about, okay, if I were starting from scratch, if I had this as my goal to be able to serve cache first HTML, what's an architecture that's going to work and allow me to do that? And that's usually how people have the most success. It's a little disappointing. A lot of people would like to just get this without running one command and everything works offline. Unfortunately, the reality is a little bit different. Sure. Sorry, which? Sure. So this just means not waiting on the network at all. Knowing locally on the device the HTML needed to respond to hopefully any URL on your site. So, there might be scenarios where you cache like 3 pages, and maybe those 3 pages would end up being cached first and work reliably fast. But if the majority of your site is not cached, those are not going to work offline. Those are not going to be served cache first. You're always going to have to wait on the network, get some sort of response, and it won't work offline and won't be reliably fast. So that's basically what I mean. So okay, and that kind of gets into the whole idea of an app for progressive web apps. So the reason why historically we've been, folks at Google, folks in the community who've talked about PWAs have mostly focused on building apps, is because the architecture that tends to work best for serving cache first HTML is the single page app architecture. And for folks who are not familiar, single page apps are kind of the idea of being able to load just generic HTML. Or we also call this like the app shell model when you're using it within a service worker. So it's the idea of loading generic HTML that then will run a bunch of client-side JavaScript, and that client-side JavaScript is in turn responsible for maybe making some network calls, maybe looking at the URL and doing some routing logic and figuring out what actual elements to add to the DOM after that initial skeleton HTML is loaded. And this works. And the reason a lot of folks have talked about this is because it works well with an architecture that many folks are already using. So if you're already building a single page app, if you're using React or Angular or Vue or Svelte or anything of that category, you might be building a single page app. You don't have to be building a single page app, so actually make sure that you are building a single page app. But if you are, then you can follow some guidance that we've had around for a while. You could go to that bit.ly link and read an article, I think from 2015, just talking about what that looks like from a service worker point of view. And basically what it looks like from a service worker point of view is that your service worker just ignores whatever URL is being navigated to and always just responds with the same cache HTML structure, and then you rely on hopefully your existing routing logic to just do its thing. So you probably don't have to change that much on the client side, as long as you have client-side JavaScript that knows how to draw the right things for the right URLs. And if you've ever played around with Gatsby plugin offline uses an approach very similar to this. I know folks sometimes associate Gatsby with static site generation, but it also kind of has single page modes, and that's an approach that works. Not everybody wants to build apps, so what about static sites? This is more of a static site meetup, so looking forward to talking about how you could do the whole cache first HTML thing from within a static site. And based on what I've already talked about, one idea that might come to mind is like, great, I could use a service worker, I could add things to the cache. I talked about tools like Workbox that kind of would integrate into a build process if you want, and it could just cache whatever you spit out. There's also just kind of standard recipes and support within Workbox to drop in some code and say, hey, serve all these particular URLs with a stale while revalidate strategy and have that work. And you just cache everything as you go. So entire HTML documents get added to the cache. So one way of doing that might be to implement runtime caching. I want to take a brief detour to Visual Studio Code for a second and run through some live demos of what I mean by all this, and just maybe help motivate a little bit why certain approaches might not work as well as others. So it's, it's one thing to see these pros and cons. We'll get back to that later. I want to actually show you 3 different versions of my 11 base blog using 3 different caching strategies and see how it goes. All right, so if you wanted to play along later, if you want to follow along now, that bit.ly link is for a GitHub branch that kind of has things set up to implement a runtime caching strategy within my service worker. We'll take a look at that right now. All right. Let me make that bigger. Okay-ish, sort of, hopefully. Get a couple more. All right, and all the code is available for this for folks to check out on their own. Okay, so let me, before I go into too much detail of what my service worker is doing, just quick overview of what my Eleventy setup looks like locally. So I have these files on the left. I realize those are probably even harder to see. What's really good about that? Make everything bigger, maybe, and then make this smaller. Find a happy medium. All right. That's a really nice thing about like Visual Studio Code being an Electron app, and just like all the keyboard commands for zooming in and zooming out for of the entire interface that you might use in Chrome work. So anyway, so what I'm doing here is hopefully a pretty standard Eleventy setup. I have this _posts directory. Some of this might just be legacy craft from having used Jekyll previously, some of the naming conventions, because I think Eleventy gives you a lot more control over having nicer defaults. But basically, I have a bunch of articles within _posts. Within there, there's also this data, _data, that has some metadata about my site, site.json, title, email, things like that. And then a bunch of partial includes as nunjucks. So one of the things that Eleventy does is takes JSON, reads it in, makes it available within templates. So I could end up like within my header saying, site base URL, site.title, things like that. And the way I have my site structured is just a bunch of partial templates, and kind of this default is something that stitches everything together. Okay, so the actual specifics, not super, super important, but I think the things to keep in mind is partial templates, some metadata, and JSON files. All right, and then some actual, just markdown files. This is offline first re-templated site part 1, so this was in 2016 when I gave this first kind of version of this talk. So, all right. We have that. I have an assets folder. I also have this source folder, and this has my service worker. So let me just spend a bit of time walking through the service worker here. It's loading a bunch of stuff from Workbox. If you haven't played around with Workbox recently, but have used it maybe in the past, I'm happy to say we know, first of all, we're TypeScript native, and we publish everything as ES modules that you could just import directly from. So that has generally made the developer experience nicer. So you see a bunch of importing things from Workbox, and it's a very short service worker. I'm basically telling my service worker to use this concept of a navigation route within Workbox. It's basically saying, match anything that is a navigation request, and use this particular strategy for responding. Use the stale while validate strategy for responding, and I could also pass it in a cache name. And then I register that route I set up. And I also have this route down here for matching anything that is under assets, images. That's my kind of static folder over here. And I just basically want to serve all those cache first. So I call this runtime caching because it's kind of not caching anything until the request is made. And then once the request is made, there's this routing logic. Over here, it's a regular expression-based route. Over here, it's saying just like anything that's a navigation. For route matches, it applies a strategy. Over here, it's still while validate. Over here, it's cache first. And at that time, kind of like build up your cache as you go. And then I just have a little bit over here, like for using offline Google Analytics, because why not? And the skip waiting that has to do with the service worker lifecycle. I'm not going to go into here. But it's 30 lines of code if you ignore the hundreds of lines provided by Workbox's libraries. So pretty straightforward from that point of view. Let me run it. So I just want to take a quick look at the package JSON. I'm going to be showing a lot of stuff that's driven by package JSON. Build is like cleaning and running Eleventy, copying over my static stuff, and then like bundling my service worker using rollup, which I like using rollup for that sort of thing. So I'm going to do that. And I created everything, and I can take a quick look in my build directory, and I have a final service worker that's really hard to read because it's all minified and everything, and I have a bunch of generated HTML documents, and that's pretty much what's relevant there. Let me try running it. I am using, apologies to the Netlify folks, I am using Firebase hosting for my blog. I do like Netlify as well, but let me pull this up. I like doing stuff in a incognito window whenever I'm starting anything related to a service worker. It's just the only sane way to do things. Start from scratch in an incognito window, close that window when you're done with one particular service worker configuration, open a new one when you're going to try something new. Trust me. All right, so this is what my blog looks like. I am not a designer. I'm going to open up DevTools though, and just show you a couple of things here, and we'll end up seeing how different approaches and end up changing the DevTools experience. So let me make this bigger as well. And the first thing in DevTools I want to show you is the application tab. This is an important tab. If you're working with service workers, it will actually confirm that your service worker is registered. So I generated my service worker. I had some boilerplate code in my site to actually just call register on that service worker. Everything's registered. You can see that's running great. Right now, there's nothing in cache storage. This is a nice viewer for seeing what's actually in the cache storage API. There's nothing there because I navigated to the site, I registered my service worker, and only at that point does the service worker even consider the possibility of starting the cache stuff. So the very first time you visit the site, any user, there's never going to be a service worker. Service workers don't like get registered magically in advance or anything like that. So the first visit needs to work without a service worker. And then the next navigation, the service worker has a chance to start controlling things. And that's what I'm going to do. Let me just click on this particular article. So I read this a couple of months ago. Core is great. So cache storage now actually has some stuff in it, which is nice. So if you take a look here, I'm not going to expand this too much. And actually, I tend to focus more on DevTools and less on content. My blog really just exists as a demonstration for how to build sites. I don't really care about blogging too much. So here's a couple of things that match what we set up in terms of routes already. So we have assets, images, PNG. That's going to be in this images cache, and it's going to end up being served cache first. Workbox has its own Google Analytics cache because I enabled that. Kind of ignore that for now. And then I have an HTML pages cache. The cache viewer has gotten really nice recently. The past few releases of Chrome. And you could really, you could see the entirety of the HTML document that's stored. You could see, most importantly, it is a full document. There's a bunch of boilerplate. There's the stuff down here. Hopefully folks can see it. It's like, here's my code for registering the service worker. It's really everything. It's everything that was on the wire is now in the cache. And that can be problematic sometimes. It's also 11 kilobytes, which for a simple page, maybe is on the low side, but for a static site, maybe it's not. I don't know. But let's see what the experience is when I click around a couple of times. I'm using a generator. Now there are 3 entries in the cache. One is for the index, and then one for each page that I navigated to already. Right away, you'll notice these two start exactly the same way, mostly. Like the title is different, but the boilerplate, the head, the meta tag, all this other stuff, that's the same. So, a spoiler for one of the things I'm going to be talking about, that's a problem. We ideally do not want to store the exact same HTML structure that's shared between different pages multiple times in your cache if you could avoid it. Sometimes you can't avoid it. No judgment. I would like to avoid it. I would like to find a way not to do that. So that's part of what's motivating this talk. The other thing that I wanted to point out is that people make changes to websites. I'm going to make a change to my website right now. I'm going to rebrand my website. I don't like 34 as a title for my website. Go to the numbers 34 instead of spelling it out. It's just me changing something that's site.json. I'm going to save it. I'm going to stop my dev server. I'm going to rebuild and then rerun my dev server. So Eleventy picks up my new metadata, generates a bunch of HTML. I'm going to start my server again. And I have a service worker now, and I have a few things in the cache. And some of the things in the cache have this, probably have to scroll down a little bit to actually show you, has like this title up over here, site header 34. So you might see what I'm getting at here. Let me click back to the main page. So the main page, this is coming from the cache. This hasn't gotten an update yet. I'm using the stale while validate strategy, so it actually is in the background fetching a new version of the HTML. But then I click on maybe styling inline scripts, which we haven't gone to before. That has my new title. That has 34 over here. Then I click back here. Okay, that has the 34. And then over here, exposing headers and course response, that still has that old 34. That's a little jarring. It's a lot more jarring when you have very drastic changes to your HTML, and you have a large corpus of things that may or may not be cached on your users' devices, and you start getting phone calls saying, why are users seeing this version of my site from 6 months ago? Things like that. That would be a nice thing to avoid. So let me just quickly touch on the offline part of things. So the nice thing is that this all will work offline. I'm just going to simulate being offline over here. Site pages that you've gone to before will continue to load. I've gone here, it'll continue to load. I haven't gone here, it will not load. So that's one of the things of runtime caching. Things that are already in the cache will continue to load. Things that aren't won't. Yes. That's definitely a thing that a lot of people do with progressive web apps is just ship a nice custom offline experience. Yeah. I want my site to work completely offline though, so I don't want to stop at that. All right, so some of the pros, repeat visits end up being cache first and fast. We didn't really get into the speed, but believe me, cache first is faster than it would be, and you have reliability. Some of the cons, first visits are network first, and then that update model. Honestly, that's the biggest thing. Storage bloat is a little bit of a thing, like you're caching HTML that technically is taking up some bytes on disk that it would be nice to avoid, but it's really, like what bothers me about this model is the idea of updating your HTML and users not seeing it, or seeing it on some pages but not other pages. All right, pre-caching. Here's an alternative. So I'm going to switch to a different branch. Let me just clean up anything that's dirty over here and switch to the branch that has pre-caching implemented. I'm going to skip most of the site structure because it's almost entirely the same and just focus on two things. I have this additional configuration for Workbox, and this is basically where I tell Workbox, hey, anything that matches these patterns and glob syntax, I would like those to be pre-cached. And this is then going to integrate to my build process and start pre-caching all this matching stuff. In this case, I'm just saying pre-cache all my HTML. And I have a service worker that's here saying pre-cache and route. And this is basically some placeholder stuff that ends up being, as part of the build process, like the actual list of URLs to pre-cache are injected into my service worker. And this part is still the same, register route for my images and stuff like that. So just here's a different strategy. Pre-caching, kind of alluded to it before. It's the idea of upon service worker installation, forcibly add these things to the cache. Don't wait till people navigate somewhere. Here's a list of URLs that I care about, put it in the cache. One of the things that Workbox does is tell you at the end of its build process, hey, here's 14 URLs that I know about, and then a total 165 kilobytes. Hopefully this is a little bit of a red flag if you start seeing, hey, I'm caching 50 megabytes, pre-caching 50 megabytes of data. Try not to do that, but you have control. So let's see what that looks like. I'm going to run serve again, and I'm going to switch to a brand new incognito window. I'm going to open that up. I'm going to actually run serve this time. And let's see, this loads. A few things are going to be different than what we saw last time. One, we have something in the cache storage right away, and it's in this cache called Workbox Precache. Here, like, whatever it is, 10 articles on my site and the index. And there's a little bit of metadata at the end for like revision information that Workbox calculates, so it knows when to update things. The important things for this, though, is that we still have this duplication. You're caching full HTML. You have a lot of duplicated content, and also, this is not going to necessarily work well for sites that have more than 10 URLs. Now we're pulling down 145 kilobytes or whatever it was. It's probably fine. If you have 1,000 URLs, you probably do not want to pre-cache the whole thing. And then the update story is the other thing I wanted to talk about. And I'm going to simulate an update by doing the same thing I did previously. Go to site.json. I'm just going to change this again to 34. I'm going to rebuild. Obviously, I'm rebuilding locally. Imagine you're doing this on your web server and the clients are not on the same machine and things like that. So it's 165 kilobytes. I'm going to run serve again. The next time I navigate to a page, it will check to see if there's a new service worker. It's going to actually pick up the fact that there is a new service worker. And then I don't know if you noticed that it just kind of flickered. I have some logic in place that it just reloads when it detects there's a new service worker. But the main thing that I wanted to point out here is that it was just 164 kilobytes transferred. After previously, the first time you visited the site, 165 kilobytes was also transferred. So I have the updates right away, but it comes at the expense of re-downloading everything. So maybe paying the cost of downloading full HTML documents once is not a huge deal, but if you're a site that knows that you're going to be updating frequently, if you change your page structure, you really don't want to have to, in the back of your head, say, am I going to be doing something really not friendly to my users and validating like 5 megabytes of pre-cached data because I wanted to tweak one thing. And you don't want to be in a situation where you start second guessing whether making changes to your site is important or not. So yeah, initial vision to cache first, entire site is reliable and offline. Cons, all or nothing updates where you update one thing, everything gets blown away. And the upfront download cost that maybe not everybody wants to pay, and then storage bloat is still a little bit of a concern. All right, different approach. So, 5 minutes left. Let me get into actually what I came here to talk about. Hopefully I could go a little late. That's cool. Okay. So leavening your service worker is, if you go to that particular URL, you will see kind of the current version of my site, what I have deployed live. I'm never going to get back to that view again. Do not want this. No. All right. Sorry. It's hard getting that particular view. There we go. Leavening your service worker is the idea of taking some of the logic that is run at build time by Eleventy and moving it into your service worker as a way of working around those shortcomings that we just saw. So I want to hit on a few different aspects of what I ended up doing, and then I'll run another build and show you what it actually looks like in network and the application panel and things like that. So the first thing that I wanted to do is get host-specific Eleventy data available as JSON. So the service worker is pretty good at reading in JSON files. You cache JSON files in advance and then make use of them. And each particular page that I have on my site, I'd like metadata about that because I need to know how to actually show the proper HTML within my service worker whenever you go to any arbitrary URL. So I'm doing this particular, I'm not sure about all the Eleventy terminology. I don't know what you would call this. This is like this is a Nunjux template within Eleventy that knows how to run over and like iterate over all of the things in the post collection, so all of my posts on my site. And it basically says, spit out this JSON for each of them. The important things, title, that's important. This is particularly important, the template content. So Eleventy is already translating my markdown into HTML. I would rather not translate markdown into HTML within the service worker, although you could, but why bother? So I'm just getting the HTML directly from Eleventy in that particular field. So that's the first thing I did, is put in this additional template that will generate JSON for me each time I build. Next thing I did, and these two slides are actually just running through the code that's in the service worker. So let me switch back, especially in the interest of time, and show you a little bit about what this actually looks like in practice. So this is in the active branch. Discard this change. All right, so the new file that I mentioned, it's this json.mjk, so that has this stuff. The service worker ends up being a lot more complicated, so I'm going to try to focus on a few most important things here. First of all, I'm importing Nunjux into the service worker. So this is because Nunjux happens to have a browser-based API. I'm then telling Nunjux, hey, you know, normally you're really good at loading things from URLs if you're the browser-based API, or you're good at loading things from the disk using the node file system. If you're the node API, I would like you to load things using this particular logic. And in this case, it's going to match things that are pre-cached in the cache storage API. So I'm saying, like, here's the path, the URL, that's the key. I would like to try to pull that. This is logic within Workbox for reading things that are pre-cached. Hopefully you find a match, and then I want to get the text of it. And that's how all of the templates and partial Nunjux templates end up being loaded by Nunjux inside your service worker. That part's good. Second part is basically just saying, hey, I'd like to set up a Nunjux environment. By the way, please load stuff using this cache storage loader I just wrote. Cool. There's a little bit of site-specific metadata that was already within that site.json, so I didn't actually have to translate this. So Eleventy will read the site.json. I want to read that site.json, and I want to pre-cache that site.json. So I just have some code here saying, hey, you know, grab the JSON body from this particular key. Cool. And then most of the complicated logic, unfortunately, is here in a bunch of statements that I can skip through a couple. The first thing is just getting that site data that I mentioned. The part that reads the actual JSON that I generated from that partial template, where it dumps out the HTML content and title and stuff like that, is over here. This requires really good coupling between your Eleventy URL structure and the way your service worker handles URLs. So jumping to that for a second, I happen to know like all my URLs for posts are like 4 digits, 2 digits, 2 digits, something.html. That ends up being passed into my post handler over here. And I know that, hey, whatever that something.html is, look under posts something.json and get that same data. Let me take a look at what was built over here. Let me just build one more time so I can show you. So that'll be the post data that I just had. And I'm basically saying, hey, I want whatever the data was, get it as JSON. Here's the context that I'm going to provide to Nunjux and wrap it in a promise, because everything service worker should be promise-based and not callback-based. I'm going to wrap it in a promise and say, Nunjux, please render using this layout, this particular context for all of the variables within my templates, and you know, if anything goes wrong, reject the promise. That'll give me back some HTML, and then I have the ability to say, hey, this is content type text HTML, and have my service worker respond with whatever the rendered HTML is with those headers. And that's how you get Nunjux to end up rendering, hopefully what works well for your actual site content. The rest of the stuff is pretty much the same. I just have one extra thing here, which is like a fallback. If for some reason something throws when you're trying to do any of this, I'm just basically saying, hey, use a network-only strategy and just go to the network and fetch whatever was there. So let me show you real quick. Here's what ends up generated as part of the build. I have these JSON files over here, exposing course headers. Here's the metadata I care about. You can see over here, the Pre-caching is more files, but it's less space. It's only 96 kilobytes instead of 165. This is all because I'm only caching things specific to each URL. I'm not caching all that shared HTML between that's reused within different pages. Let's see what this looks like in the browser. So I need to start again. Fresh window. Doesn't work offline until the first time you run it. Running, and at this point, similar to what we saw last time, I have some stuff in my pre-cache, but what you see in the pre-cache is a bunch of JSON files and a bunch of NJK files, basically. So I'm not caching HTML. I have these templates. I need the templates. I have this JSON. I need the JSON, and that's going to end up being stitched together inside the service worker. So you might gather from the previous example that I'm going to show you what the update process is like now. So first of all, things load quickly. That was obviously pretty quick. Things load offline, even for URLs you haven't gone to before, because we had the JSON for that particular URL already cached. That's nice. Let me go back online, make some changes to my site. Same thing. 34, blah, blah, blah. Build. Serve. Okay, so if you take a look in the cache, the only thing I changed was site.json. We have site.json pre-cached somewhere right up here. So the old version had 34 here. Let me make this bigger, sorry. We navigate to a new page. The service workers detects, hey, there's something new. It downloads the updates. The only thing it's going to end up downloading, if you look at the network tab, is a new copy of the things that changed. So site.json, also index. I'll talk a little bit about index later. So it downloads the new site.json with the title 34, sticks that into the cache over here, title 34. And most importantly, now let me go offline. Here are pages I've never been to before. 34. Okay, so we've gotten to the point where, let me just go back on, yeah. Initial visits are cached first, even for URLs you haven't gone to, assuming that you take the step of pre-caching JSON. Again, be respectful of your users. If you happen to have 1,000 URLs, pre-caching 1,000 JSON documents probably doesn't make a huge amount of sense. You could kind of mix things in like a runtime caching strategy for your JSON that's specific to each URL, and then pre-cache your site structure. But the way I have things set up right now, initial visits are cached first. The entire site works offline. Updates are cheap because the only thing you download is that, like in that case, I made a change to one JSON file. That's the only thing that had to be re-downloaded. And efficient storage usage, I'm not like taking multiple copies of my HTML and seeing that scale to multiple megabytes and stuff like that. The real con with this still is like that upfront download cost, so please be respectful of what you pre-cache. That was not me being done, unfortunately. Sorry, let me just go back real quick. Okay, a couple of to-dos and enhancements, and then I will move on to the next bit. This is my site. It's grown organically. I've been in the back of my head saying I really need to package this up and be more of a starter kit for folks who are starting from scratch. I would say right now, if you could fork it and just get rid of my content, put in your own content. If you actually know about design, you can design something that looks nice. And hopefully it'll all just work. It doesn't really play as nicely with some of the Eleventy kind of things that would be harder to move into a service worker. So like short codes, custom tags. I don't really know how to do that. I've been in touch with Zach a little bit about it. I have an in now, his brother. So maybe I'll try to learn a little bit more about exactly what that would entail. But if you're doing crazy things in your Eleventy setup, beyond just like standard nunchucks templating in particular, it might be harder to translate that into your service worker. I'm just caching index.html. I'm not trying to dynamically render it. I need to do some pagination stuff in the service worker, and I'm not exactly sure how to do that right now. So I just, right now, have a big index HTML that I cache with a list of everything. And kind of the other thing that I've been looking into is like, nunchucks works. It is not the lightest weight library. I think it's about 80 kilobytes it's pulling into the service worker. It's still fast enough, but like what are some other things that might be a little bit more native to the platform that might be appropriate? I've been looking into some things like lit-HTML. It's difficult because you really need a templating language to do things like includes and stuff that just doesn't exist as part of JavaScript. So I'm not really sure what the answer is there. If folks have their own templating language that they like and think it might be a good fit for this, I'm happy to chat about that. Some additional resources, so to learn more. So this site I've been talking about, jeffy.info, I don't really have that much on my blog, but you know, if you wanted to actually go to the blog and see what the experience is like, that's the site we've been talking about. That other link there is second link, static site scaffold. One of my colleagues who works in Chrome OS developer relations has been trying to do more of a starter kit type experience using Eleventy. It's not really using the same rendering. He's kind of doing his own custom like almost Apache includes inside the service worker type thing. It's pretty nifty. Check that out as a potential starting point. I think it's a bit of a work in progress still, but he's actively developing it. That third link, PWA architecture, that's a talk I gave at a conference a couple years ago, just talking about same general topics, not really with a focus on Eleventy, more of a focus on doing server-side rendering and matching that server-side rendering inside a service worker, and doing streaming and adjacent to these topics. And that final link, SWHTML payloads, another colleague of mine, Phil Walton, just blogged about his setup that he's using for his blog, where he's combining a bunch of cached data, not with Eleventy, but using Workbox and putting that into a stream that ends up streaming HTML to the browser. So definitely related to this topic, but slightly different approach. And yeah, that's what I had to talk about. Apologies for the bits that are rushed. Apologies for the bits that were not rushed, but should have been. And I'm going to be around for questions. I don't know if we have time for questions now or 2 questions later, whichever makes the most sense.
Mm-hmm. As you sort of broke it down, like, are people generally like mapping service workers to like web components essentially? I mean, if they like think on like page level and then maybe down on like this code partials kind of level, and then
I wouldn't say like web components.
like,
do you mean web components like? Okay, gotcha.
I can understand like I'm making this web component, and here's how I go about thinking about how I want to see it offline, or like I care less if this thing is shows up offline, so not rendered. And I just didn't know if there's like
that's totally legit.
Patterns
there definitely are patterns. Yeah, there definitely are patterns, and I think patterns for handling failures that are the most important. I think like a lot of these patterns are the same, like if you happen to have colleagues or if you yourself are working on native apps. Native apps have to deal with this all the time. Like the native app model is that you have basically the shell that could open up at any time, but maybe the network's not available. And like your news application says, hey, sorry, couldn't load the news, or you know, your whatever app shows you the last tweets, not anything fresh, so stuff like that. So I think it's really a question of taking those existing patterns that probably people you work with or maybe you yourself are already familiar with and just bringing them to the web, using service workers to do the actual loading and using fallback logic. So service workers are promise-based. Some of what you saw in there is kind of like this like idea of a catch handler. If some of your loading fails, you could respond with a completely different response that just says whatever you want. So that's definitely a way to think about it. Yeah.
Any other questions? All right, thank you, Jeff.
Cool, it's a pleasure.